and we are going to close all the models that we have opened. So you can do File, Close All, or you can right-click and close all, etc. Okay, so for this exercise, I would like you to create a new model by doing File, New, Model, and I'd like you to call this Simple Gender Income Disparities. Okay, and I'm going to place this in a certain folder. You don't have to do the same. But for the model time units, it's going to be a little bit arbitrary since this is going to be a model where we're not adding a lot of dynamics, but it'll be days. Okay, actually, I'm sorry. Make it years. Make it years. And I'm going to do browse, and I'm going to put it where I need it for the boot camp, just so that all the models are in one place. It's called Simple Gender Income Disparities.
And you can't have spaces.
You cannot have spaces. You can have underbars. If you want to do something kind of space-like, you can have underbars. Okay? Let me just put this in the right place. Okay. Sydney, there we go. Okay, and then models built in class. Models built in class. And again, I will endeavor to place these up on the site. Okay, models built in class. Here we go. Simple gender income disparities. I did File, New, Model. Okay? Okay, now, ladies and gentlemen, when you create a new model, you see that it lends you to two things. One is it puts down a main class for you. That's the stage in which the agents will stride. And then it puts down an initial experiment. Okay. Finally, there's this database item that I think I'll have Dylan describe a little bit later this week. Okay. Ladies and gentlemen, we are going to now begin by introducing a theory of personhood here. We're going to introduce an agent. So this model is this agent-based model is worthy of that name. So in order to do that, what you will do is you will right-click here on the model as a whole, and you will do New Agent Type. Please watch what I'm doing and keep it in mind, because we're going to be doing it many times during the boot camp. Let me rehearse that again. You can right-click on the model, say New Agent Type. Okay? And this agent type will be person. Now, please also make a note of this. Person here is spelled with a capital P. Okay? Capital P. And we're going to use capitals to denote what are called classes. These are kind of, it depicts our theory of personhood. It depicts all possible persons. When we have a given person, we'll refer to them with a lowercase b. Oh, that's a given person. That's Jeff, or that's Dylan. Capital P for person is here denoting personhood, personness. Okay, set of all possible people. Okay, and we're going to say just like later we'll see color depicts with capital C depicts all possible colors. I'm going to say finish, and there it is. There we've added to our model. You'll notice that agent classes are depicted with a kind of Da Vincian emblem of the measure of man. Okay.
Excuse me.
Yes.
Can you repeat that step on how it began?
Sure. I will, for others, don't follow me, but I'm going to delete this guy, okay, and I'm going to say right-click on this model, and I'm going to say New Agent Type,
Yes.
capital P person, and then I'll say finish, okay? Okay, yeah. Okay, if we go to this person, we'll find them singularly bereft of characteristics, okay? Okay, now, ladies and gentlemen, the first thing we're going to do is go and give this person an appearance, okay? We're going to give them a visible appearance. So for that, we're going to go to the palette, and I'd like you to go to the agent palette. And actually, the construct we'll be using is in many such palettes. But here is called a parameter in the agent palette. How did I get to this? Basically, I went to the palette and I looked down here for the measure of man. Okay, that's this red thing. I clicked on it, and I'm going to go up there, ladies and gentlemen, to person. Okay, sorry, to parameter, and I'm going to drag the parameter in. And this is going to be called. Excuse me. Okay, I'm now in trouble. Okay, I said income, but that's actually incorrect. I'm going to delete that. We're gonna drag in sex. Okay, lowercase sex. Okay. This person is going to have a particular sex. Okay, and next I want to go to the presentation palette, and I want to lend them, excuse me, I'm going to spice it up a bit. I'm going to go down here to the pictures palette, and I'm going to add in a person. How did I do that? I went down to pictures in the palettes, and I added in a person. Okay? So I went down here to pictures, and I added in a person. Now notice I'm dragging these things into person. Why? That's because they're characteristics of the person. Okay? A person is going to have a picture associated with them, and they're going to have a sex associated with them. Okay? Certain sex, a certain depiction. Are we okay with that? Okay.
I'm still unsure about the difference. I know that I've seen this reflects object-oriented programming, right? But why is a person got a capital P, but sex doesn't have a capital S? Because underneath it, you're still going to have male and female as options.
Capital, that's a great question, John. Capital indicates the set of all possible, so set of all possible persons. This indicates personhood, okay? Person, it's encoding kind of a theory of personhood. And capital P person is the set of all possible people. Capital SEX would indicate the set of all possible sexes. But a given person has a specific sex. They have a very particular sex associated with them. They're going to have a particular income. They're going to have a particular age. And as a result, each of them is going to have a specific value for it. We are, in fact, going to introduce in this very room, in just a few minutes, something that represents the set of possible sexes. But this person, at any given time, a given person is going to have one specific sex. The theory of personhood is going to associate each person with a specific, particular sex.
So this is the part of, if I wanted to relate it to object-oriented programming.
Yes.
The person is the capital P, because it's the class, and
Yes.
now we're giving all the parameters
Yes.
in how we're defining that person. So what important characteristics we want that person.
That's right. So this would be, in object-oriented programming, this would be considered an attribute of the person or a field of the person that's storing their particular sex. In this case, it's a parameter, which is a more or less always a fixed value, a fixed specific value for that they're going to have. And the parameter is going to denote what the assumption is about this particular person's sex, and it's going to communicate it to this person from where they're created. We're going to see that in just a second. It's going to be from a population. Okay?
Yeah.
Okay. So, ladies and gentlemen, I would like you now to go to projects, and we're going to leave sex in in a state that's, we're going to come back to this in just a minute, okay? I'm going to teach a lesson here. So we're going to go to main. We're going to go down main. We were in person. We were adding attributes of persons. We're going to go to main now. And I'd like you in main to create a population of persons, okay? For this, we're going to drag over from person and into main, okay? Notice when we do this, its emblem lies there. And we're going to say population. That's what we're going to give it as a name. Now, you might have not done that in time. So you might have dragged it over and somehow just left it as person. If so, you can type it here, population. Okay?
And it doesn't have a capital P?
No. It's a specific population. So person with a capital P is a set of all possible people. It's their personhood, personness. This is a specific population of people. Might represent a city, might represent a town. Okay? And ladies and gentlemen, we're not quite done yet. Does anyone notice on this, if we want this to represent a population, what do you think we have to do? There's something down here in properties that we have to do yet. What is that thing?
Choose the population of agents.
Yeah, we have to set it to be a population of agents. Okay? Okay? So
Do you always have to do that, or is not?
well, if we want it to be a population, yes. If we want it to be just a single agent, we could leave it as single agent.
But a population is always a population, isn't it?
Yes, but it doesn't know. It's not smart enough. This could represent, when we drag it over, it could represent a population or a single person. It's saying, which do you want? And here we want a population. Okay? Okay. This is a population. The initial number of agents will be 100. Okay? Okay. Now, ladies and gentlemen, I would like you now to run this model. Are we okay with that? Okay. Okay. So who could tell me, how do I run this model?
Press the green thing at the top.
Yeah, you can do that, although I tend to go like this. In order to be very specific about which one I want to run, I like to do it from here. Right click on this and choose run. But yes, you can do it with the green button on the top.
Any particular reason why you choose to do that?
Yes, because it's very specific about which scenario I want to run.
If you add extra X's down there and you press the green button at the top, I'm not sure what experiment.
Yeah, it's not clear which experiment is he going to run. Often I'm not sure. You can actually pick.
Can I suggest that you recommend to the AnyLogic people that they actually put somewhere that what is the experiment you're running on the thing?
Yeah, that's a good idea.
Because it actually doesn't tell you. Like,
It doesn't tell you when you're running
Yeah,
it.
absolutely, I agree as well.
Oh, it's terrible.
Because when you were running it before, and I vagued off for a minute, I wasn't sure what thing you were running, and I was looking at there and going, how can I work out which experiment?
Yeah, I know
you're
it's-
running? I can't work out which experiment you're running. That's really hard.
No, but it I don't think it tells you. Let's try, unless it's the latest version, because definitely it did not used to. Let's go see here. If we call this simulation 1, would it actually say something different at the top? If so, then they've done no. See, it still says simulation. It's kind of an unfortunate thing. It's a really bad thing.
But they could, I was just saying, you could ask them to change it.
Yeah.
Because when you're running things, you could be running something you really didn't intend to.
Could you choose, so if you
Uh-huh.
stop,
Yeah. Yeah.
oh, yeah, and if you try and run it from there.
From this guy?
Oh, no, sorry, where you were, yes.
Yeah.
Yep,
Run.
there's the drop down box where it says experiment, you can choose.
Yes.
Is it possible to choose which, like, experiment you can, if you have multiple experiments, you can choose it from there?
I don't think so. I've never actually done that. Let's try a new experiment. I'm just gonna, don't do this yourself.
Yeah.
I'm gonna try a new experiment here. I've never actually frobbed that drop down. No, I think it's just this one. This one is the only one displayed. I've never seen something else displayed here.
Yeah, me neither.
Yeah,
Never thought about it.
never thought about it either. Yeah, okay,
Each experiment experiment could have different, like, there could be an error in the code for one experiment rather than the other experiment. So it wouldn't run all of them.
Because it's not compiling them all at the same time.
Yeah.
It's compiling one properly.
Yeah, I mean, you could definitely engineer around it, but that's just not the way it's
Okay, so ladies and gentlemen, were you able to run this? Now, it was not a terribly enticing run, not riveting. But ladies and gentlemen, you'll notice that we actually do have some indications it's actually running. Here's a population of 100 people. If you click on that, it lists, but it also lists a rather unseemly fact.
Yeah, save as.
We'll come back to. You could also drill down. Here's each person, and you'll notice what their sex is. Their sex is 0.
Oh, you can't. Oh, no.
Okay? Now we're going to go through a little bit of a thinking here. Their sex is shown as being a floating point number. We need something else for their sex. We need it to be encoded in a way that communicates what sex they are quite clearly. Now,
How do you also know it's a floating point, not an integer?
well, when I ran it this way, there's two ways. So how did I know just then? If I went here and I clicked here, it says 0.0.
Oh, right.
The other way is if I went to person, I went to sex, it says it's a double precision value. So ladies and gentlemen, this is a very important factoid. Parameters are associated with types, okay? So there's a type, and that indicates the set of possible values that sex could take on. This is saying it could be any double precision value, okay? Okay, ladies and gentlemen. So we're going to need to change this. And now I'm going to introduce capital SEX, indicating the set of all possible sexes. So I'm going to provide a way where we can describe a particular person's sex as male, a particular person's sex as female. And the way we're going to do this, ladies and gentlemen, is we are going to here right-click here, okay? And we're going to say new option list, and it will be capital SEX. Oops, what am I doing? Oh, I did something terrible. Actually, it's not too terrible, but it was not what I intended to do. Right-click, new option list, and I meant to say capital SEX and then specify the elements. Okay? Now, if you didn't, and you created it, you could do it in the properties window. I'm going to say, let's put females first. Female and then male. Okay? There we go. Okay? This denotes, capital SEX denotes the set of all possible sexes. A given person is going to have one specific sex, hence low SEX. But here, this is the set of all possible sexes. Capital SEX. Okay? Are we okay with that?
So can I just ask, anytime you right click on that top little AnyLogic symbol, are they all classes? If you choose anything from there?
On the left there?
Yeah. Are they all classes?
Are these all classes you're saying?
Yeah.
Yeah, they are.
No, like anything that I choose from up here, would that be a class?
Up where?
Anything you choose from up here, if you went
Oh,
through,
yeah, those
these-
are all
these
adding.
classes.
Yeah, except not the database and not the library. But this is, Java interface is kind of like a class without an implementation. Dimension is, it doesn't quite function as a class, but it's,
Not quite.
no,
But
not
AnyLogic
quite.
option
Pretty,
to Java
most of them are.
class.
Yeah. Okay. So a class represents a set of all possible values. It kind of characterizes a class of possible things. And in this case, we've added sex as a class. And notice it's a capital because it's denoting a set of possible values, set of all possible sexes, male and female. And now, let's go back to person by double-clicking on person and clicking on lowercase sex. And ladies and gentlemen, the type of person is now of sex in person is going to be what? A capital SEX. So it's going to be drawn from the possible values of as described by capital SEX. So they're going to have a particular sex, And that sex, the particular values can be drawn from the set of all possible sexes as depicted by capital SEX. Okay, so it's going to be either male or female. Yes, Kurt?
I have a question just to see if people are understanding it.
Yeah.
If we change the name of that small s sex, what would change in the person?
Sorry, you what?
So it sees there, we have the parameter called sex, right? Small s, sex. Can I change that to be anything, or does it have to be SEX sex?
Be anything.
It could be anything.
It could be gender.
Yeah, so you could write as gender, you could write as my gender.
You can write my sex.
Yeah.
But there's no,
Yeah.
this is,
Yes.
Yeah, what has to be capital SEX is this one. It's referring to the set of all possible sexes.
Yeah.
Okay, ladies and gentlemen. Ladies and gentlemen, let us now go and we're going to put in place sex is for people. But first let's run the model. Let's see what happens. So we're going to run it. And here's our set of possible people. And click on that. Let's go down and drill down to the population. And here's the sex. But they don't have a specific sex implied. Remember that a parameter encodes an assumption, but it also provides a way of communicating that assumption. And no one's told this person what sex they have to be. What is it that gives the value of a parameter? What is it that tells the person what to assume for their parameters? What to assume about their characteristics? Wherein does that live? It lives, ladies and gentlemen, in the place that creates them. So if you have an object like a person that has a parameter, the thing that gives the value of that parameter is the thing that creates it. And in this case, what creates these people? What defines their characteristics? Ladies and gentlemen, that is none other than the population. So back we go to main. Back we go to main, down main. And ladies and gentlemen, in the population, we are going to find, so click on the population in main. If you scroll up, you will see that there's a place for us to specify the sex of a given person. Okay? A given person's sex can be specified here. So first, we will just make use of a fixed value. We're going to say female. Everyone in this model is going to be female. Okay? Okay, we're just going to say that, and we're going to run this model and see what happens. Okay?
So just because you told me to do this, I typed in FE and space autocomplete, and I don't get female as an option.
Okay, well, that's the most interesting thing, and I appreciate a good attempt there. So let's, I think this may be one of the few places, no, it fills it out for me. Okay, Kurt, could you assist?
This has been a little bug actually in this area.
Okay.
Female.
It's true. It's spelled right. That's what I'm doing, right?
Okay, now if we drill down, we'll find people all female. Scroll among them. So let us lend some variety. Okay? Ladies and gentlemen, we have a population that's all female. So that's a start. But let's make the population have different characteristics. Okay, so I want to take directions from the group
Every
here.
once in a while, I've noticed that with option list, it doesn't always.
I want to take some directions from the group. So, would you folks like to see 50-50, or would you like to do a custom distribution?
Right, and I would do.
You want to do custom? Okay, so what we're going to do to impose a custom distribution is we're going to go over to the palette. I was going to introduce it sooner or later, so I might as well do it now. Ladies and gentlemen, I'd like you to go down to the palette, and I'd like you in the palette to go to the agent palette. Once again, with the Da Vincian emblem. Okay? And from there, I'd like you to drag in a custom distribution into main. Note please, 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 before you drag something in, note where you're at. What's displaying? You want to be very clear about into what you're dragging it. One of the most classic mistakes you can make with AnyLogic is dragging it into the wrong thing. And bizarre things start to happen. You don't know why. It's because you thought you added to person, but you actually added to main or vice versa. So please go to main, and from main, I'd like you to drag in custom distribution, and I'm going to say, sex distribution. Okay? There we go. Distribution by sexes. Okay? Now, what sort of type do you think this is? A continuous, a discrete, or an options? It's easy to think discrete, but it turns out this thing we added called sex is in fact an option list. Okay? And so it turns out this is over options. And you notice if you say options, it allows you to pick it. And I want to make it over sex. And now, ladies and gentlemen, I can specify what fraction do I want to be female, what fraction male. Okay. And actually, this is just number of observations. So I'll make it, 52% female and 48% male. There we go. Yes?
Those don't things, they don't need to add up to 100, right?
No, they don't. They'll just take it
They'll
proportionally.
normalize them.
Yeah, that's correct. Yeah. Okay? Number of observations, female, male.
So if you think you added it up to 100, you find it
Yep.
Question?
Do you mean like problematically stuff it up, or do you mean just the numbers and ratios?
Just, it wouldn't be.
In other words, it would hide your error from you.
Yeah.
Yeah.
It won't in fact enforce it. There are other ways to tell it to enforce it. In other words, you could have code that will check, is it add up to 100, but it doesn't do it. Automatically, it will sort of renormalize, which is of arguable desirability. I agree.
But you could, if you were building it yourself, instead of doing 52, you could do 0.52.
That's true.
You could write it as a percentage so that you know that that's how you were coding it. Whereas if you wrote it as a 52, you could just say, 52 in my database, I have 52 observations.
Right.
And I have 48 observations.
Right. Okay. Okay, so ladies and gentlemen, that's half of it. And now, does everyone have this? Okay, so what we did is we put in this distribution. We chose here that it's an options, and we chose the option list to be capital SEX. Are we okay with that? We okay? Okay, and then we put in the options. It already said male and female because those are the options in the option list. And we put in 48, 52 and 48. Are we okay? Okay, people ready to go forward? Maybe you could help out a bit there. Okay. Okay. Ladies and gentlemen, the next thing we have to do is to go to population. And this is where we assign the sex for each person in the population. Right now it says female. That means everyone is going to be female. When it creates each person, it's going to say, what's their sex? And it just says female now. Now we're going to draw from that distribution. And how do we do that? Ladies and gentlemen, we say sex distribution. Just like that. Sex distribution. Remember, autocomplete is your friend. Remember, autocomplete early. Remember, autocomplete often. Sex distribution. I do control space, and you will want this begin paren, end paren after it.
And how do you know you want that? Because I did autocomplete, so I get two options.
You got two options.
One without the.
That's correct. So if you did it without it, it would be saying, for their sex, make their sex a distribution, which doesn't really make sense, an entire distribution. This is how you call the distribution. In other words, you request the distribution return a value. You're asking it to do some work. It doesn't need anything to be given to do that work, and it's going to return a value for sex. An analogy would be, in high school, and when you were doing trigonometry, you wrote sine of 90 degrees or something, right? SIN, begin paren, end paren, 90 degrees in the middle. The sine function needed the angle to do its job and return a value to you. And it's just like that in Java. You need begin paren, end paren around any arguments it needs to do its job. Those are called arguments. Any information that a function needs to do its job needs to be in between these parentheses. Now, if it so happens it doesn't need any information to do its job, it just knows what to do. It doesn't need any information. You just have no things in between the parentheses, but you still need them to say call it. If you didn't have that, you'd just be saying the distribution itself and say make each person sets the distribution, which doesn't make sense. But this is saying for each person sets in turn, draw from this, call this, boom, and then it's going to go on to the next person. For their sets, draw from here, boom, and it's going to keep on drawing from that, although it doesn't always make that noise. Okay?
Don't jump like a kangaroo.
It doesn't jump like a kangaroo either.
That would be a nice feature. We should ask them to add that better version of AnyLogic.
Yeah. Okay. So are we ready with this? Okay. Ladies and gentlemen, let us run this model then. Save early, ladies and gentlemen, save often. Control S is your friend, or Option S, or Command S. I'm not sure what it is on a Mac. Okay, right click here. And now I'd like you to run it. And now let's go to each person in the population. Here's a male, here's a female, here's a male, here's a female. Are we okay with that? Okay. Oh, what happened? Okay, Alan, can you help
I
there?
don't think mine's doing it either. What's it supposed to be doing?
What's that? So what you should be able to see here is if you run the model, okay, and now you go down to the population, male, female. Dylan stands ready.
Mine apparently is only female. Okay, so there's control S.
Is it only female?
They were just clicking the box to the left rather than the one to the
This one.
Yeah.
Oh yeah, no, ladies and gentlemen, you want to click this box here. This goes between different population members. So this will go population member 20, 21, 22, 23. Okay, ladies and gentlemen.
It's like when you click on the population, you cycle through each of them, you look at each of them.
So this again, when you
When you click at the population,
yeah.
that means you look at each of the individual.
So in other words, if we go down and we say population, this allows us to see each person in the population, and here this will go to the so this is the first person, the second, the third, the fourth, the fifth, the sixth, etc.
Right, awesome, yeah.
Okay, and that's extremely useful. That's, ladies and gentlemen, I want to emphasize that it's very useful for figuring out what's going on in the model. To dive down to level of particular people and see who's in what state, what are they doing, are they in fact, are transitions being accomplished, etc. Very useful.
I think if you had chosen the second one, that would be.
Okay. Okay, ladies and gentlemen. Okay. Ladies and gentlemen, are we ready to go on, or would you like another minute? Okay.
Roberto was just asking if you can see if you can put this in a list of any kind. Like, can you see a list?
Can you see the list of the population in
The
years?
sets?
Like, in other words, see them enumerated by sex? We could do that. I'm trying to figure out when to do that.
But you can't just do it now, right? It's not an auto-
It's not something that's auto done, but it would be very easy to do. I'm trying to, maybe we'll do it later, that sort of thing, if that's okay. It's very quick to do. Okay, ladies and gentlemen, next, I would like to go give this person an age. Okay, I'm going to give him an age. Ladies and gentlemen, we're going to make, we're going to drag their age in. Now, How are we going to give them an age?
Okay.
What do I need to add to them?
A parameter?
We want to add a parameter. Okay? So,
Sorry, what is the difference between parameters and variables?
so
I meant to ask this in the morning, but I
we're going to introduce we haven't yet formally introduced variables, but let me direct the answer to you and for anyone else who knows about them. And then we'll come to introduce variables. We'll emphasize it again. A parameter encodes an assumption, typically fixed, and it communicates that assumption from the point of creation to the thing that has the assumption. In this case, it's a person, right? Right?
Yep.
Each person has an assumption about their sex, okay? Are we okay with that?
Yeah.
And the fact that they have a parameter means not only is there an assumption about their sex, but let's go back to main, to population. Population here communicates their sex. It calculates this, and the parameter is used to communicate to that person what their sex is. This is actually for each person in the population. Do you remember the kangaroo hop? Remember that? For each person in the population, Jeff would like to see it again, no doubt. For each person in the population, person 0, it calls this, it gets a sex, and it communicates it to the person through their sex parameter. The next person, it calls the same, it communicates it through their sex parameter. So the parameter encodes typically a fixed value, and it communicates it from the point of creation, in this case the population that encloses these people, to the person. Now soon enough we'll see open populations where people are added in through birth or through immigration. And there, where it creates them is different than the population itself. But once again, the parameter will communicate that, okay? Yeah. Very important point, and I'll come back to this point in just a moment more generally, okay? So a parameter encodes a fixed assumption, and it communicates the assumption from the point of creation to the thing that holds the assumption.
Yeah.
A variable, by contrast, is almost invariably created to encode a variable quantity that's not an assumption, it's just something that's calculated in the process of the model, of running the model, and it's not told to the thing that holds it. It's something that might keep track of some bookkeeping, like how many times I've been infected over time. Do you remember that model we had earlier where it was each person kept track of the number of times they got infected? That would be changing over time. And it's not an assumption we give to them. It's something that's calculated over time. That's how variables are best used.
So that's an endogenous quantity.
It's an endogenous quantity. My hat is off to you.
So parameters are a
You've made my
subset of
day.
class.
Sorry?
Parameters are a subset of class.
Of
Class?
no, parameters are not subsets of class. They are
Are they like the attributes of the class?
they're attributes of a person, a specific person. Okay, so an instance of the class. So we talk about there being the person class, which denotes all people. We talk about instances of the class being specific people. I'm an instance of a person class, a specific case of it. So like we could talk about Springer Spaniels, and then my dog is a specific Springer Spaniel. It's an instance of Springer Spaniel, and that dog has a certain length of ear or something, and that's an attribute of that dog. Sex is an attribute of each particular person. So each person, this describes personness, personhood, the class, and it describes, it's like a cookie cutter, and with that cookie cutter you can make many specific persons, and each of them will have a specific sex. Each of them will have a specific attribute, their specific sex. So when I run this model, here we go. When I run this model, person 0 has this sex here. Person 1 has this sex. Person 2 has this sex. That's a characteristic of that particular person. It's part of personhood, part of being a person in this model that they have a sex. But the specific value for the sex will differ from person to person. Does that help at all?
Yeah. So I would have said it was just about like if you had a model and you wanted to do dogs, you do dogs, then you want to talk about the sex of the dog. You might want to talk about what type of dog it is.
That's
you might
right.
want to talk about the colour of the dog.
The age
you might
of
want
the
to talk
dog.
about the age of the dog. And all of those things are what in AnyLogic calls parameters, but object-oriented programming calls attributes.
Attributes.
And that's what a parameter is, I think.
Yeah, it encodes an attribute, although attribute is also used, unfortunately, in object-oriented programming to denote variables as well. That in object-oriented programming, when we talk about an attribute, we talk about a field. It could be a fixed thing, and a parameter is almost invariably fixed, or it could be something that changed over time. And unfortunately, object-oriented programming doesn't have the normal distinction between these. And so we end up saying something like the final attribute, or it's a constant attribute. I teach software engineering, and unfortunately I need to remedy this. Modern languages like Scala do make that distinction. You distinguish between a val and a var, but that's I don't want to go into that here. Yes, Kurt.
I think it's, I mean, for me the way I thought of it is just that they're all attributes. So they all characterize an attribute, right, or a characteristic of that example, of that person, right? One of the attributes could be weight, for example. The weight changes over time, right? Age changes over time. So then the parameter these parameters, they don't change. You design practice is to keep them the same, because the reason why they don't change is because those are the initial values of those things. So you might have initial age, that could be an attribute at the beginning of the model, but then you have the dynamic age, which you just call age, and it's a variable. But you don't specify, you're not allowed to change the value of that variable.
Of the parameter.
Of the variable. You're not allowed to change the value of the variable from the person class in the same way that you do with the parameter. When you start your model, right, your parameters are defined by your model, but your variables should be defined by the logic that's evolving throughout within your agent.
If they're endogenous.
They're endogenous. They're all endogenous. Well, I guess the
No.
values of the parameters are not endogenous.
No, they're not.
That's the next
Not endogenous
question
to the
I was-
person, but they can still be endogenous.
They can be endogenous to the model, so,
Yeah.
yeah.
So the
So-
parameters, you can't actually say parameter is endogenous or exogenous.
Well, so the value of the parameter is specified outside of the person, so it's exogenous to the person.
Right, yeah.
Yeah,
We have
it's
a question
told to
over
the
here.
person. It's told to the person.
Yeah.
We'll get a question over here, maybe we
So
can.
the parameter is fixed, it's not possible to assign.
You actually can assign it, but it's bad
It's
practice.
bad practice.
It'll be a bad thing with a capital B,
Yeah.
at least by my book.
Okay.
AnyLogic doesn't ask me,
Capital D.
but no, it'll be bad. It'll be bad form to assign to a parameter. It would just not be a proper way of doing things. I occasionally see it about once every few years. I see a compelling case. Yeah, okay, you can do it. But generally speaking, parameters. When you see a parameter in any logic model, it almost invariably denotes a constant property, and it's good to adhere to that convention to give clarity to the transparency of models. And it's very rare you have to depart from that.
So yeah.
Constant to the individual.
So
but
just
not
treat it as
constant to
fixed for
population.
now, in the same way that you treat, I before E except after C, until you realize that it's not always the case. But for now, just treat it. That's the rule.
Yeah. As a general rule, it's almost always used in a fixed way, and it's useful to sort of adhere to that discipline. Okay. So anyway, here's sex. Now I'm going to introduce, ladies and gentlemen. I want to generalize this notion of a parameter because it's a very important one. I want to have now the population of people in which these people are embedded. I want to have that population differ from experiment to experiment. I want to have each experiment run the model with a different assumption about the size of the population. How am I going to encode an assumption in AnyLogic? How am I going to communicate an assumption? Through what mechanism? How do I encode an assumption in AnyLogic? Using a parameter. So we're going to add, ladies and gentlemen, to main, a parameter called population size. Population size. Okay? Okay. Now, ladies and gentlemen, What do you think the type of this parameter will be? From what possible values will it be drawn? Is it a Boolean, something that's true or false? Is it a double precision value like 3.14159? Is it a sex?
Interval?
It's an integer, an int, an integer. It's something like 0, 1, 2, 3. Okay? Now, with this parameter, you'll notice with parameters, and Kim, I should have probably indicated early when you were asking about differences. With parameters, you specify default values. So if nobody puts an assumption, puts in an expression to use, this would be used. With values, you have initial values. What's the initial value of a variable, rather? But with parameters, you have a default value. This is just what will be substituted if they don't say what to assume. Okay, it's not an initial value. It's sort of a default assumption. So we're going to have a default of 100. Okay? 100. 100 is our number of people. Now, if we just left it like this, would this in fact be the population size? Maybe I'll make its default value 1,000. Let's make that. Would it be the population size? Would suddenly change to 1,000? No, why not? What do we have to do?
Initial number of agents.
Yeah, for population, it's asking what's the initial number of agents, and it's 1,000 here. What do we need to say?
Take it from population.
Yeah, we have to take it from population size. So this dot population size, okay? The population size in me. This means kind of me, my population size. Okay?
So we put 1,000 in the population again.
1,000 is the population size. And then we go to population, and for the initial number of agents, we say, use my population size here. Okay?
Now you don't have parentheses.
No, I don't. That's because it's not a call. It's just the name of the parameter. So this is asking sex distribution to do some work for us. Sex distribution it's got to be told, compute me a sex. And so we're actually telling it to compute a sex. That's where we're telling it, hey, do something. Go off and do this with a begin paren, end paren. Here we're just using the value of this thing. So if we want to just use the value of sex distribution, we could do this, but then it would be an unhappy camper because it doesn't know what to do with the distribution. It needs a specific sex.
So when you use distribution, you need the bracket.
No, when you have the distribution, you want it to draw from it. That's when you need the bracket.
Okay.
The distribution by itself, mentioned without the bracket, without the parens, it'll just be a distribution, and it won't know what to do with that. It says, you want me to be a sex, and you give me a whole distribution. What am I supposed to do? You want to draw from it, and that's why you need the begin paren, end paren.
Right, okay.
You want to draw values and do this. Draw value from this distribution. And that's why it comes with that, okay? Okay.
You only want just the value for there as well.
Can I phrase it a slightly different way?
Sure.
So, again, we kind of go back to the math class example. If your teacher writes up on the board, these are the properties of tan, and then they list off all the properties of the function, what it kind of looks like, how it changes in the graph, how you might change the parameters. When you just say tan, you're not thinking that needs to compute anything. You're kind of saying, this is the concept we're talking about. It's the same thing with AnyLogic. If you don't have those brackets on there, you basically said, all right, I'm going to tell you something about this distribution. I'm going to maybe ask a few questions about it. But the second those parentheses show up, same thing with tan. If those parentheses are there, then you start thinking about it differently. It's like, okay, I'm going to get a value out of this. The teacher's going to ask me a specific question about, what does the input angle give me back out? In the case of this distribution, this is a special way of saying, all right, distribution, I'm not talking about your properties. I just want you to give me a value. I don't care how you get it, just give me something back. So it's just a slightly different way of interrogating that little distribution. If you don't have the brackets, you might be talking about its internals and its properties and what it kind of does. With the little brackets, it says, all right, now it's time to do work, just figure out an answer for me.
Right.
Does that make any kind of sense?
It does,
Did that
but it
just add
doesn't-
more confusion?
It does, but it doesn't explain to me why this population size, which is also returning a
Exactly.
number, doesn't say, why don't you go population size
And then get a number.
open-end bracket?
Yep. Yeah,
Because population size doesn't have any work to do. It's just a value of population size that you want. The value of the distribution is the distribution itself. Population size is actually a number. It's an integer. It holds a number.
But it doesn't have to be an integer.
No, but we told it it is an integer. So if we had said that this is a sex, or that this is an agent, or what have you, then we might have had to ask it to do something with it. But here it's just a number, and that's all this needs. The initial number of agents needs an integer. And we had said this is an integer, and hence
So could you not still make it work by going population size, open parentheses, end parentheses?
it'll be an unhappy camper.
It won't work, yeah.
You can't call an integer.
Another way of
Yeah.
looking at it is,
Because,
with this name, like this name tag is kind of like population size. You can just look at it and say, oh, it says Dylan. But if you were to ask me, what's the meaning of life? You can't peer inside my head easily enough. I have to sit there and think about it and get back to you on that sort of thing. Name tag, just like the parameter, is basically visible for anybody to see and take a look at. But any kind of computational operation where that needs to really figure something out, that's where the braces come in. Does that kind of make
Well,
sense?
Some kind of thing for
Yeah.
human distribution.
So maybe I can think of another way to phrase it. It's already kind of been touched on. So if I say 1090 or sine 90, maybe we know does anyone know what sine of 0 is right off the top of their head?
One.
Zero.
Zero. Sine of 0 is 0. So if I say sine 0, what is sine 0? 0. If I say what is sine, you're going to say it's a function that starts at 0 and it goes between minus and positive 1 and it goes on forever in a sinusoidal
Yeah.
wave, right?
Yeah.
So if I say, okay, well I need to put sine here. I put sine here. Now, did I put the number or did I put the function there? I said I just want sine, so I put the function there, right? So if I wanted a function as an input, I would just say sine. I don't have to say sex distribution,
Right.
I just say sex
That's right.
distribution without a bracket. So in this case, population size doesn't have a function. It's like x in a mathematical equation, right? So what's the value of initial number of agents? X. Well, we know that x has a particular number. It's
Yeah.
5 or 10 or 25 or 30 or whatever, right? So it's just a particular number. I say I want x.
Okay, so then why at all put this population size? Why don't you just write 100?
And that's the next step.
Because,
That's the
well,
next step that he's showing.
we'll see this.
Yeah. It's a very
Because
good
we
question.
wanted to be able to vary it.
It's the next step. You'll see it.
Yeah.
Something like, because we are referring to population size, initially we said the population size variable equal to 100. So we want to refer the same value here in the population. So then if you just change that, if you go to the individual population size, so if you change to 1000, so it automatically updates that because we are referring to the same variable here. But when you're talking about the sex distribution, so we have to determine, so at each and every case, we have to determine what will be the sex of each and every individual. So it can be taken from the distribution of 60% of male and 40% of female. So we are picking out with that probability, one value. So that value is not a fixed value. So at a given time it can be changed. So that's why we are giving it as a function. But in the previous case we are referring to a specific value.
But her question was why don't we just put 1,000 there for population size?
Yeah.
And the reason is because basically this population size, this parameter, if we put a parameter in person, where do we set that parameter?
Well, Kurt, but
Okay,
yeah, let me.
still get there.
Yeah. So I'm motivated adding a parameter because we want to be able to change it from experiment to experiment.
So instead of changing it at both places, you just change it at
Well, more than that, you don't have to change the model to change your assumption about about this population size. So let's go see this, right? Now that we have this, let's go now add some experiments. So this simulation has a population size of 1,000. Let's go add a new experiment, which is going to have, large population, right? We're going to have a population size of 100,000, right? And here we'll have a model which will have a single single person, right? And that's going to be a population size of 1. These are 3 different scenarios for the model, and we could run any of them. So here we're going to run the large population, and here we're going to start, and we can go, okay, it's actually still running, it's actually running low in memory, okay, fine. Here's our population size, 100,000. So we have actually got a model where we have 100,000 people in the population, and we could go browse each of them.
I've started a large population, but I don't know where I'm changing it.
Sure. So here we go new experiment, and here will be medium population. And for medium population, we're going to set a population size of 50,000. Right? 50,000. So here, population size of 50,000, we are just running the model with different values of population size. Why would we want to do that? Well, we may want to run the model under different scenarios that are very different, but without changing the underlying model. None of these alternative scenarios require us to change the model at all. We simply run the model with different assumptions. And my point in emphasizing this, I want to draw attention to this key point about parameters. Earlier, Kim asked, why use parameters? So a parameter encodes an assumption and communicates it from the point of creation to the object that has that parameter. So when we had a person, and the person had a parameter, their sex, we communicated that parameter, the value of that parameter. We said what to assume about it and communicated it from the population, because the population created the person. It drew a particular value for sex from the sex distribution, hence the parentheses. And it communicated it to person. By contrast, ladies and gentlemen, when we had a population, a parameter in main, the assumption to use for that parameter in main was dictated by the thing that creates main, which is the experiment. Here, for the large population, it communicated an assumption of 100,000 to use for population size from this experiment, 50,000 from this experiment, 1,000 from this one, and 1 from this one. Each of those used a different assumption about population size. And the reason that they could each assume different things about population size was because population size is a parameter in main. And because the experiment is responsible for creating main, it takes responsibility for specifying the assumption about the parameter, in this case, about the population size. Does that make sense? So, if a parameter lives in person, the assumptions about that parameter are set, as we'll see amongst other places, by the population in which that person lives. That's the thing that creates that person. If a parameter lives in main, the assumptions about that parameter are set by the experiment. And it's extremely useful to be able to change those assumptions for different experiments. Hence, moving from a situation where we had this hard-coded, where every time we needed to change the assumption, we'd have to come back and change this from 100 to 1,000 and run the model again and change it to 500,000 and change the model again. Instead, we just code that with a parameter, and all we have to do is, for different experiments, change the values of that parameter. Does that make sense?
Yeah.
Are we okay with that notion? Parameters. They encode an assumption, and then they communicate that assumption from the point of creation to the thing that holds the parameter. Does that make sense? We are on the same page here. Okay.
One question. If you're running an experiment in one city and then you want to run the experiment in another city.
Yep.
So that will be, your parameter will change to Melbourne versus Sydney, for example?
You could do it that way, yep. Yep, you could do it that way. So you could set the, you could tell it, well, okay, I'm going from Melbourne to Sydney, so load all the characteristics of that, the appropriate city in from a database and use that. Or you could set all the parameters that need to be different, like the population size, its, you know, its information about its geographic location and so on. You could set those with parameters. Okay? So that would be one very viable way to do that. Yes?
We had a good conversation here when you were running the large population model.
Yeah.
So some people were running out of space.
Memory, yeah.
So I don't know, maybe some people would like to know about this.
Sure. So ladies and gentlemen, yes, when we were running the very largest population, it turns out there's different ways to run models in AnyLogic, and one of them involves visualization. When you're having visualization, it's going to require more space. So when you're running a model with a very large population, you can go to the assumptions about that particular experiment, and we can pull down and indicate how much memory we want to devote for this. By default, it's 256 megabytes. I'm going to change that to 512, which will be devoted to this. And by running this, it turns out that we will actually be able to run it much faster because of that. It'll be much, much less clumsy. If it's running with 256 megabytes only, it'll be running very slowly because it's really needing to economize in terms of the memory. It has to work hard to do that. Although, indeed, okay, this time it isn't. Oh, sorry, I ran, gosh, did I run 99? Okay. Large population. Oh, sorry. I changed this back. Okay, just for illustration. This dot population size, okay. So in short, you will sometimes have to worry about the amount of memory allocated. If it's a very large population, you may need to increase this to a large amount. And one of the indications is down here. You notice that this is red, and what that's saying is it's pretty maxed out memory. It's going to be doing a lot of work to be able to run here. It's going to be running very slow as a result. On the other hand, if it had a larger amount of memory, it'll be able to run faster. And one of the reasons we can do this on a per experiment basis is that we experiments that are more demanding and sometimes less. And now with 512 megabytes of memory involved, it runs much more comfortably and it takes less to run. Okay, good. Any other questions about those basics for parameters? Okay, we're going to add another parameter now. And in the interest of time, this parameter will be income. Okay? So we're going to go here, parameter, and we're going to go to indicate, we're going to drag in a parameter, and it's going to be income. Okay? Great. It's a new parameter in person. Remember, it's person to which we want to add the income. Each person has an income. Let's talk about each person. The notion from object-oriented program is that instance of person, a particular case, a particular instantiation of a person. Person describes the theory of personhood, and a particular person will have a specific sex and a specific income. Okay? Okay, now, ladies and gentlemen, what I'd like to do now is to put in place for the double precision value for income, I would like to put a default value here, okay? We're going to draw this value from a distribution, but instead of being a custom distribution, an empirical distribution like earlier, we're going to draw it instead, ladies and gentlemen, from a parametric distribution. And I'd like to introduce you to the probability distribution wizard. So take a note of this. Up on the right, upper right, and I think this may vary by AnyLogic version, if people could look. But in the upper right here, there's something called choose probability distribution. And this gives dozens of different distributions that AnyLogic supports for different different values. And you can actually experiment here as to ones that might match your needs. So we're going to have a log normal distribution that's going to have a mu of 10.5. We're going to have a sigma of 3.5 and a minimum value, ladies and gentlemen, of 1, okay? Sorry, of 0. Okay, ladies and gentlemen, so here we are, log normal with mean and sigma, and we're going to say okay here. And it will actually insert for us the requisite code for doing that. Which, and this is, you'll notice again the much feared parens, these parens. So log normal is a distribution, and in order to draw a value from the distribution, it needs some information to do its work. You know, before we had a custom distribution, empirical distribution, just an empirical distribution, we sort of draw from it, so it didn't need any values to do its work. But with a parametric distribution, we have to tell it what to assume for its mu, what to assume for its sigma. In other words, log mean, log standard deviation, in fact, minimum value. So it needs these values to do its job. It says, tell me what to use for mu, sigma, and the minimum, and I will return for you a value. So this is drawing from that distribution. This by itself, as Dylan emphasized, this by itself, or maybe Kurt emphasized it too, this by itself is just the distribution. But we want the distribution, we want to draw from it. We want to say, hey, distribution, give us back a number. Calling it with this is going to give us back a double precision value. Okay? So we're going to draw from that distribution. Are we okay with that? Can we run this model?
Why a log normal?
Because it has a long upper tail that reflects the inequities in our societies.
Okay.
Well, it's true, unfortunately. So here we go. So here's a person, just to indicate this, here's a person with a modest income. And here's a person with an income that's, over 40 times higher. And here's another person with a kind of middling income. Here's a person with a very low income, middling. And here, ladies and gentlemen, is a well-heeled female.
Yes. You see, that's where your model was wrong. You forgot to add in the inequity.
Yeah. So, ladies and gentlemen, we could scroll to the population. This, ladies and gentlemen, is another millionaire male.
Yes.
And okay, ladies and gentlemen. So we have our distributions here.
How do you assign? Oh, that's in person.
Sorry?
Oh, I know where. Sorry.
Okay, who needs help? Yes.
Just a question. With the income, what the type is double? I might have missed it. What does double mean?
Okay, double means a double precision value. So it'll be something like, it'll be a floating point number, like 3.2 or 2.65 or 1.81 or what have you, 3.14.
There's only a certain number of types you can have. So
Yeah.
logical,
Yeah.
integer, double,
Yeah.
which is floating point.
Yeah.
And then those other, we had that type thing for shared sex where you could choose male or female assumption with gender.
Yeah. Yes.
I mean, there's usually 3, there might be a 4th one, I can't remember, but logical, integer, floating point.
Yeah. It could be true or false, or an integer, or a floating point number, or it could be a string.
Date.
Yeah. It dates, and here it's like the sex, a person, etc. Okay, so ladies and gentlemen, so we've just seen that. Ladies and gentlemen, I would like now to go put in place a bit of logic that's going to allow us to report on what the mean income is in this population. Okay? Ladies and gentlemen, let's go, and we're going to go to main, and we're going to have a bit of reporting, because it's, generally with these models, when the models run, we want it to report on certain characteristics of what's going on. So I'd like you to go to main, and ladies and gentlemen, I would like you to go to person here, or sorry, to the population. Excuse me. Okay? Population. And I'd like you to scroll down in the population to the statistics area. Do you see that? In population? So this is a characteristic of the population. It's in statistics. Now, statistics, it has some warts. It's not perfect, but it's a pretty nice feature of AnyLogic, I gotta say. The ability to define these statistics declaratively. So I'd like you to add a statistic with that big green plus that is green when you hover over it. And I'd like this to be, the first one to be mean income. And this will be an average income. Well, they still haven't put median here, I don't know, but this will be an average income. And we're going to ask it to take the average over each person's income. So for each person in turn, it's going to go to the population and take their average. Now, each person in turn, it's going to call item. Okay? Item. And so over what is this going to take the average? It's going to take the average of their what? Of their income. So we need to say item.income. Each person in turn is going to call item. The first person in the population is going to call them item. And it's going to say, what's the value I need from you? I'm going to say my income, item.income. And then the next person is going to call item. They say, what do I have to take from you? It's my income. The next person is going to call item. It's just going through each person's population, taking the average over their income. Okay? Are we okay with that? Are we okay?
I have a question.
Average over income, yeah.
So, items, for example, if you have a population here as person, so item refer to the person.
Yeah, item, it says in a most inscrutable way, the embedded object. It's a thing that's in the population.
Right. Okay.
So if it were a population of clinics, it would be that each clinic in turn will be called item, and it would. And this basically says, for each thing in that population, what do we take its average over?
Yeah.
Okay. Are we okay with this?
And you always have to have that item. There's no way.
It'd be strange, because if you didn't have item, you wouldn't be taking the max or the sum or the min or the count over the different things in the population. You would just be taking it for each person in the population, you're taking the max of some other thing. It would be a very strange concept. I really can't imagine. I've never seen a case where it doesn't mention item. Because it's almost by definition you're doing a statistic over the population. For it to be meaningful, it needs to be referring to each person. Okay? Okay, ladies and gentlemen, item.income. Okay, ladies and gentlemen, may I introduce you to this build button. This build button is also your friend. Okay? You want to press and you'll want to press it early. You'll notice when you press it, if it's a happy situation, it will say build completed successfully. Now, if it's not a happy situation, it'll still be a good friend to you, and it will tell you your problem that you need to fix. Like any good friend, it'll tell you if there's a good problem, if there's a problem. Okay? Okay, ladies and gentlemen. So I'd like you to run the population now. Run the model. Okay? So I'm going to size 50,000, and I'd like you to go click in the population and take a look at that. What is its mean income? $24 million. And you'll notice if you look here, some of the incomes are higher than others. I mean, there's many that are well below it, but it's because it has a very high, long tail on the positive side. Okay, so the mean is, it turns out, well above the median. Now, ladies and gentlemen, now we're going to sadly introduce a feature that's sadly part of our landscape, which is inequity in distributions of income between males and females. We're going to capture that here. Are we ready? Same work, but different incomes. So we're going to make the income of a person dependent on their sex. Are we ready for this? Okay. Ladies and gentlemen, there's many ways we could accomplish this, but we're going to do it this certain way. I'm going to introduce for you a feature of AnyLogic. Boy, do I wish AnyLogic was Scala now. But yeah, so we're going to go to main. We're going to go, in fact, to the population, because population in main is the place where we set the characteristics of the particular people within it. So if we had one population maybe for Melbourne, one for Sydney, and they were simulating both at the same time, the Sydney population would characterize the characteristics for people in Sydney, and Melbourne one could specify characteristics for people in Melbourne. So let's go to population, and then for the income of this person, I'd like you to do the following. And this is going to seem a little bit strange. Okay, just like your instructor. Sex double equals male. If so, we will use a log normal distribution. So what we're saying is, hey, is the sex of the, sex, we have to say self.sex. If they're male, sorry folks. Oh man, I wish I didn't have to tell you. Sorry. Worst of all platforms except for everything else. Self.sex. And how do you know that? Well,
Java, don't you?
No, you don't. It has nothing to do with Java. It has everything to do with AnyLogic.
It's a feature / bug.
It's
a feature.
It's a feature, but it's it's a less documented feature. Therefore, I teach my students it so they can know about it. Ladies and gentlemen, we're going to have, I'll put this up on the big screen because this will seem a tad unfamiliar to most. But this is what we're going to have, just like this, okay? Just like this. Just like that. Okay, so I'm saying, is my sex male? If so, I'm going to draw from this distribution. Otherwise, by implication, I'm female, and I'm going to draw from that distribution. I'll get that back up here just after, yeah. Okay. Okay. So this is kind of like an if expression. You know, in R, we actually have an if expression, and in fact, in Scala, there's if expressions. And in fact, many languages are if expressions. So if this is true, we're going to draw the value from this distribution. Otherwise, we draw it from this distribution. Okay? You notice this is a question mark. So if that's true, draw it from here. Otherwise, from that.
And if you had more than one option?
Then you could nest them, or you could create a function which would just ask which is true. So there's ways to prettify that in a quite nice way, but I'm not going to go into it right now. But there's ways to do that nicely. Okay.
This the question mark and colon thing is actually just a shorthand for something more readable. But if you ever just need to have something quick and dirty like that, say, for instance, if you're teaching a class and need to fill out a field really quickly, then the question mark colon works out really well.
I happen to feel it's not that ugly, but I know they corrupt you in early. That's not that bad.
So
if you don't use question mark and semicolon, what do you use?
You could use if, you could create a function and use an if statement. Personally, I think this is at the same level as an if statement of ugliness, but
So we've had a few people here ask, why use self versus say item or this?
It's a very good question. Okay, so okay, so I would like to try to crack at this first. Okay, so the only place, to my knowledge, that item is used is in statistics. Okay, it's going through each person or each thing in the population and it's asked about its characteristics. It used item to refer to the current thing, and probably it would have been better if they had used the same word, item, in both cases. Item. This self, this here, the word this would be tempting. But the thing is, we're inside of main. And so this refers to main. It refers to what I'm in, where this code is actually taking place. It's actually in main. So this refers to main, not to the particular person. Here we're creating a person's, or defining a person's characteristics to be, so the person can be created. And the way that, so first it says their sex, and then that person be created is called self here. And so if there are later things that refer to their income or to their sex, maybe there's something to do with their education levels, and it depends on both of these or something like this, you'd be referring to self. That's referring to the thing being created here. And there's no deep reason for that. It's just that AnyLogic needs a way of having conditional distributions or having rules for this that are contingent on values for the same person, that have already been set. And they chose the word self. Kurt, do you want to comment more on that? But this definitely we counterindicated because it refers to main.
Yes, so this is a Java thing. It's within Java, since AnyLogic is built in Java, it has to use this. All of these words, this, item, and self, they're all words that are kind of like possessive words. So like the word sex can be whose sex. Right? This is sex, self sex, item sex, whatever. So all of these words are simply allowing us to point kind of which agent are we trying to work on, or which agent's value is this? Because in Java, and it's true probably most of the other computer languages, is the scope of the word the word sex can be valid only in certain parts of. Yeah, that's not meaningful to talk about, but let's just skip what I just said at the end there. But the point there is just to say, like, we want to know whose value we're changing. So it's basically like just a word with an apostrophe s.
Yeah.
And then you have which level do you? So object-oriented programming means that you have you can have your main and then your population. You can have like a main and a household and then people. Yeah. Then at each stage you could have an attribute that has the same value name. Yeah. So then you just have to know which value name am I going to associate that with. Yeah. So in this case, this is something that's not explicitly within Java, this self dot something. Because you can understand here what you're implicitly doing is you're setting the value of an income for a multiplicity of agents. So whose value is that value? Self. That's whose value it is. And that self is an arbitrary single person from the population.
Well, I wouldn't say it's arbitrary. I mean, self refers here to the person being created.
It's an unnamed. I mean, the name of self is the person that's being created in that moment.
Yeah. So
a generic, I should say.
So you could think this is creating an initial number of agents, and for each of them, it's setting their sex and their income, etc. And for each, this is just a convenient way to refer to the characteristics of the person being created. So if you've already set them, like their sex here, then it refers to their characteristics. Yeah.
Just wondering, because you're setting up your attributes based on other attributes.
Yeah.
Is there any order that you have?
Yes, there is. Yeah, they have to be in the order. This can only depend on. It's only meaningful if this depended on things before it. It will not enforce that. This is why I teach this. I mean, this is not an uncommon need to have one attribute be contingent on another. The probability distributions for a later one depend on earlier. And you can often decompose them conditionally in this way. Sometimes we want to draw them from a joint distribution, and one way to do that is to decompose it into marginals and conditional distributions. But, and so it's quite common that the later ones may depend on the earlier ones, and I just wanted to show people how this is done. I know this is, maybe I shouldn't have done it this time. It's just that a lot of people come to me with this question if I don't do this. How do I make the characteristics with respect to education depend on their income, or the characteristics of income depend on their sex and education, or something like that. And it's a common question, so I want to throw it in there. But self here it's one of these things that, I just memorize because it has to be used here. And unfortunately, it's not something, this is something I have a beef with. There's no thing that tells you to use self here. That's a bad thing with a capital B. Yes?
I have a question.
Yeah.
Is that anywhere, or is that possible to have a list of these things?
Yeah.
This dot, item dot, blah, blah, dot.
Yeah. Yeah, I can do that.
Situation?
I could do that.
Yeah, that would be tremendous.
Okay, could someone take that down? One of the TAs take that down?
Sure.
Thanks. I would also note that TAs could do that.
I would also note that participants could do that.
Well,
you guys could write down as we go along.
I am writing down, but I don't
Okay.
think.
no, it could be, okay, so it could be good for our boot camps to have that. So I'd like that idea.
I'm making a note.
Thank you. Okay, so ladies and gentlemen, now we have males and females here. And males and females are associated with different incomes. So let's put in statistics that will compute the average income for males and for females. What do you think? Is that okay? Ladies and gentlemen, how do we put in a statistic for this population? Where did we do it before? Whither did we go? Yeah, in population down in statistics. Okay, ladies and gentlemen, how do I go add 2 more statistics? I want you to tell me what to do now. Click on add. Ladies and gentlemen, listen to Joe's voice. Okay, so click on add. Boom.
That's on main?
No, it's in population in main. So we went to population, we scrolled down to statistics. So now I'm going to say mean female income, and this is going to be an average. Okay? And over what will it be an average? Can anyone say? It'll be over, ladies and gentlemen, over what will, ooh, that sounds unfavorable. Over what will it be an average? Yes, item dot income. Okay? And now, ladies and gentlemen, how are we going to set, but do we want this to perform over each person in the population in turn? Call it item, item, item? Is that what we want? No, what do we want it to do? Yeah, we want it to only do it for the females. So how are we going to write a condition that tests whether this person is female? What's the person's name?
I think it's self.sex equals female question mark.
Oh, it's very close. It's very close, but it's ruled just as Thomas Huxley said. It's a beautiful theory ruined by an ugly fact. What is that? What is that ugly fact?
It doesn't know what the sex is.
No, it's not called self here. It's called something else. I'm sorry. Go on.
Item? Item.sex equals female question mark.
Oh, okay. Item dot sex. We're okay. Is it equals? Double equals. We're testing. Is it equal to? And so when you test in Java, you put double equal to. It's saying, is it equal to? That's when we use the double equals. If we just wanted to say make their sex female, we would say item.sex equals female, but then AnyLogic would warn us because it said that's not a condition, that's an action. Okay? At least Jeff likes it. Okay. Ladies and gentlemen, this is what we want. So next, I want you to tell me. You could inform me in a stentorian Greek chorus. How how am I going to take the mean male income? What am I going to put in place? First of all, what type will it be? Average indeed. And what will the expression be? Item, not income. Good. Good. You folks are cranking along. And what will its condition be? Excellent. 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 Okay.
Question.
Yes.
Well, I know we define males and females with a capital M and F. Is it case specific?
Yes, it is. And the reason we do capital is because of this.
Yeah.
We define it as part of sex, and then we it is case sensitive. So Java is brutally case sensitive. Would you not agree, Kurt?
Yes.
No, thanks. Okay.
It's not so much that it's case sensitive, it's just that it has to be exact, which means it's case sensitive, but it's more than that, like it has to be exact, yeah.
Okay, ladies and gentlemen, let's run it now. Shall we run it?
Well, because it feels brutal when they're enforcing when you.
It's like, oh man, you're just because of that. Yeah. Okay, ladies and gentlemen. So if we wanted to see those statistics, where could we see them? Wherein would they live? Yeah, we go click on the population. So the mean female income is, well okay, you may not do too bad, but 827,000. Okay, and then mean male income is 20 million. Woo!
Sorry.
Is this yearly?
It doesn't know it mainly.
I should have been more careful with my choice of parameter values for the distribution. So, good question. Maybe it's lifetime income or something. I don't know. Anyway, good call. Okay, ladies and gentlemen. Okay, we're almost done, but we're going to do something a little bit different now, and we're going to finish in a flourish. Okay. Okay. So, ladies and gentlemen, what I'd like to now do is to go to this. Okay, ladies and gentlemen, I would like you to go to person. Okay, and excuse me. I'm sorry, folks. Let's go to Maine, and let's go to the population in Maine. Okay. Ladies and gentlemen, go to Maine and go to the population in Maine. Dylan, could you help here? Yeah. Right there? Yeah. Okay. Okay. So, ladies and gentlemen, if you go to Maine and you go to the population in Maine, I would like you to go now, and I would like you to, in the initial location, I would like to set it so that they're located in the specified point. Okay? Okay. Okay? And I'd like to place for the X location uniform between 0 and this dot space width. Okay? And similarly for Y, between uniform between that and space height. Okay? So what I'm doing is I am setting their X location to place them as drawn from a uniform distribution between 0 and whatever the width of the space is, and their y location is between 0 and the height of the space. Okay? Now, notice this. This is, so Maine is asking itself, what's my space height? You notice the begin paren, end paren. It's asking, what's my height? And it doesn't need any information to be told in order to do its job and return a value. So this is returning a number, space height, this dot space height. This is returning a double precision number back, so it'll go between 0 and whatever number this returns. Okay?
So space height and space width is the built-in function.
Oh, yeah, but you can actually tell it what space widths and heights to use when you run the model. So, or when you set up the model. And so this means you could change it over time, and this code won't need to change.
Okay.
It'll just always adapt nicely to whatever the width and the height are. Okay? Which, I mean, I could hard code this to be 500, but then if later I go change it, I have to remember to update it here. It's just a pain. So I might as well just tell it, hey, just whatever height it is, whatever height the screen is supposed to be displayed on, just place them randomly between 0, their Y location being randomly between 0 and that.
So you just do this as a matter of course in all.
Yeah. Yeah. Okay, ladies and gentlemen, so let's run this thing. Yeah, occasionally you will find me lapsing. Okay, and I'll put 0 at 500, and that's bad. And I should be whipped with a wet noodle by my students for doing that. It would be considered very bad form for a software engineer to be engaged in such tomfoolery. Okay?
We weren't able to bring wet noodles in on this plane, so.
Oh, you wouldn't get it.
Okay, so you should see something like that. Do you see something like this?
Yeah.
Okay. Okay, ladies and gentlemen, we're almost done. We're virtually done. And that's good because the food is waiting. Okay, now, ladies and gentlemen, I would like now to set the appearance of the person to be based on their sex. So I'd like you to go to person. I'd like you to set the shape, Okay, so if you go to person, you can actually go try to do this through this little icon here. If you frob enough, you'll be able to get it to select the requisite area, but it's a bit of a pain. So I would suggest going and grabbing this thing through this menu on the left here, and going down to the presentation under person, going to shape body. Okay, it's under person. So if this is collapsed, you'll have to go like this and expand presentation and expand person, and therein lies shape body, right? Okay, ladies and gentlemen, we're getting close to being done here. For the appearance here, do people see the appearance? Okay, mark my words. We're going to do something a bit delicate. Under fill color, we're going to set that. We're going to change it from an equals to just be used if it's some fixed color. We want it to actually change based on the characteristics of the people. So I want to change it to be this little recalculate thing. Okay? Ladies and gentlemen, we want to set this to be this dot sex. Well, you tell me. Ladies and gentlemen, how would we set it so if they are female, they will be yellow, otherwise they will be gray, spelled in a way according to American dictates. So according to the American Imperium, how would I do that?
Yeah, you're going to have to, it's not self.
It's this. Yes, it's this. It's in person. Okay, this dot sex, and then what would I say? How would I test if they're female? Double equals. Oh man, you folks are good. Okay. What's that? A question mark. Good. And if they are female, we'll make them. This could be a contentious choice. So I've just decided I'm going to yellow and otherwise gray. Okay. Yeah, you can pick your own colors if you want to. Okay. I got in trouble one time. Okay.
Pink and blue, didn't you?
Yeah, mumble. So some crowds man in blue, others take me to task. So yellow and gray seems to be, but now gray is getting contentious because of the. Maybe I should make it yellow and black. Okay.
I think one time we actually had a group that made men pink and women blue.
Yeah. Yes, we did. I know.
It used to be like that.
Okay. So, ladies and gentlemen, so I'm not going there. So, ladies and gentlemen, this is the color to use for their fill color. Okay. Now, this is the penultimate crown jewel. Okay. Why this? Well, because I'm in person. It's my sex. It's whoever's the current person, their sex. If their sex is female, they should be yellow. Otherwise, gray. Drab. Okay? Are we ready? Can we run it? Okay, let's run the. Okay, here we go. And what do we see? Okay, nice. Okay, ladies and gentlemen. Okay, who needs TA help? Okay, TA springs. Okay, second TA. Who needs TA help? TA stand ready. Okay, we're just about done here, folks. And now what we're going to do is we're going to do something that it's going to take me out on a limb. Okay, ladies and gentlemen. I ad-libbed in a way here that I'm going to regret, but ladies and gentlemen, okay, so what I'd like you to do is to go as follows. I would like you to go to shape body, and I'd like you to scroll down from fill color, go to the position and size, and I would like to set the scale X here and scale Y. Okay? Okay, now I'm in trouble. Okay, so ladies and gentlemen, I would like to set the scale X to be the log of this dot income plus 1.
Ah, that would look awesome.
I'm so glad for your vote of confidence. I just wish I shared your conviction.
If I thought, if what I thought was, that thing, but I don't know.
Okay. Okay, and the scale Y will be the same thing. Now this gives me the willies to repeat that, but food is in the offing.
I don't know.
Okay? So ladies and gentlemen, I don't think this will look beautiful, but it'll be a start. Okay, are you ready? Let me put this up on the big screen. So this should really be plus 1.0. Let's be careful about that. There are times where you can fall afoul of the language semantics. Okay?
That's too big.
Thank you. Okay, let's make it, thank you for the feedback. Let's make it 0.1 times this. Instead of just that, we'll make it 0.1 times that, okay? 0.1 times this thing. Okay? I don't think this is going to be a very successful ad lib. Okay. Okay, shall we run it? Okay, here we're going to run it. Let's run it now. Okay.
Very successful ad lib.
Yeah.
Well, sometimes sometimes you win, sometimes you lose.
I think this is awesome because it really reflects the size of the income.
Yeah, so you'll notice if we go down to the level of the individual.
On the wrong side of the distribution.
Yeah, you see as you go through each person, like here's a wealthy person, and here's here's someone of means, and here's someone of very modest means, right? Okay, so ladies and gentlemen, I just want to reflect on what we saw.
Yeah, I think so.
We just imposed distributions, we learned about parameters, and we imposed distributions for people's parameters as drawn from, on the one hand, a custom distribution, which could have been an empirically grounded distribution. In another case, we drew it from a parametric distribution. We actually made the distribution to use for a person depend on other characteristics, to wit, sex, right? So we made their income depend on their sex. Beyond that, ladies and gentlemen, we put into place a layout for the people. We distributed them at a random location between the width and the height of the space. And then we further, ladies and gentlemen, declaratively associated the model with certain statistics. And these statistics were associated with the population, but can report for us the mean incomes for males and for females, as well as to the population as a whole. Right? Remember that? We could set their characteristics, these statistics. But ladies and gentlemen, more than that, ladies and gentlemen, we went and we set the characteristics of that person according to their shape, so that their color was distinguished by their characteristics in a declarative way. We didn't have to write, heavy lifting code for this. We didn't have to set the fill of this in some code. We snippet of code, and that could encode their sex, a little rule for their sex, and we wrote a little rule indeed for their size, and that produced, a most pleasant of depictions here, where actually these have meaning. So, ladies and gentlemen, this, I have to confess, as a modeler who came to AnyLogic, I guess I first used it about 12 years ago or so. When I first saw these sort of depictions, I thought, well, those are kind of eye candy, but maybe they don't offer much real substance. But in truth, often you learn a tremendous amount by looking at data visualized in the model. You actually can recognize real patterns that would otherwise elude you. And I've been caught in several situations where the visualization gave me great insights I otherwise wouldn't have had. So these depictions are not just eye candy, they're useful things. And the fact that we can declare many features of them declaratively without writing a lot of code, but just writing simple snippets that represent rules has significance. Okay? So visualizations are a key part of some of the more powerful features of AnyLogic. And so much of what we've done here is declarative. It focuses on what needs to be represented and less on the how, and it will take care of a lot of the details. Okay? So that's all for right now. We're going to have a break for a snack of sorts, and we will regroup at what time, Jeff?
22.
22. Okay? So
Don't be late.
So that will be another 20 minutes or so. So thank you very much for your patience. Thank you for your questions. And I look forward to regrouping with you. Sorry? Sorry?
You want some green tea?
Oh, yeah, green tea would be great. Thank you. Thank you very much.